Okay, today we are going to see how we complete this cycle once we have the state space form produced from the bond graph method. How do we actually produce block diagrams and then also the Simulink interface. So let's take a look at this. And here we go. We have this simple example that we have proposed. We have the bond graph model of this in here. This bond graph model was put into the CAMPG software, and we say, okay, to obtain the state space form, we need to run CAMPG SYM and make sure that we define the outputs. So if we do that, once we run that, the CAMPG is going to give us this indication. This is the input, this is the state, the space vector, and if you just run that file directly at the beginning, you are going to get A matrix and the B matrix. For this, you need to recognize that the output, if we want the voltage across the inductor in here, V sub I, that is this one is E sub 8, but the inductor, the voltage across C is E sub 5. So if we go into the files and define the two outputs for the C matrix, we will we define the two outputs, we will obtain the C and the D matrix, and this way you see the state space form, it's completely defined. Just so that you just that I remind you what I'm saying in here is let's see, this the form that we have at the top, this one here. So just to make sure that you see it as I write, this is the x dot forming here is equal to this A matrix that you see here times this state variable vector, which is like this, plus this which is the B matrix times the vector of input. See, that's what you have in here. On this one, what you have is what happened in here, I think, is I wrote it down x dot in here. This one is the y is equal to the matrix C times the state variable x, vector x, plus the matrix D, that is over here. Let's go and put it right. This is the D matrix, and then multiply by the vector of inputs in here. So everything depends on the state variables. So this is the state variable vector, and this one is the inputs vector, which is both the state variable vector is also here, yeah, and this input vector is also here. Okay, so far so good. We obtained the state space form. You may ask now how we produce block diagrams from the bond graph model. The basic premise that we have is to produce always block diagrams for Simulink using the first order equations, right? So one thing you can do very easily here is, if you go to the MATLAB file in here, right, go and take a look at the equations that you have. Alright, seeing here, I'm going to steal these equations from here and using the sniff, and then we will use these equations to produce the block diagrams that we need using the techniques that we have learned before. So what happens is, now if we go to the to our notes over here and I paste this in here, you realize this equation that you see in here on the left hand side, that one right there and this one right here are the two equations that we could use to build a block diagram. This, of course, remember, those are the block diagrams of this part, but we also need the block diagrams for this one. So it is important that we have the differential equations, but also we have the output equations. So let's go take a look where the output equations are by going back again to the file that we have. Here are the equations, but the output equations, do you see here? This is the first one. It says E sub 5. So I am going to use my sniffing tool again to pick up this and have it available for me to work over here. So this is my output equation in here. Let's see how we do this. Okay, we need the other one. Okay, this is how I had it. We need the second equation, and so I will go back over here. Where is the second one? You see it's right here. So let's just use again the sniff, and then I will pick it up and do this one right here. I put it in here. So now what do I have? My task is to produce a block diagram using these equations and using these two output equations. So here's what I would do. Remember what I told you? Start always with the summation point. Well, this is very easy because here the summation points are already defined. So in here, in fact, what you have of the summation point, the output of this summation point is dp sub 8 dt. This is what you have. And then the input here, you have one that has the on this side it has minus 1 over this, well, this is r sub 7 divided by I sub 8 multiplied by p sub 8. That's what this is. And the other one that you have in here is this one, that is q sub 5 divided by c sub 5. So this equation is in here already. Now what I would suggest we do, because the summation points are important, I would do the summation point for the second one as well. You see in here, this one is going to be my dq sub 5 dt, and it has one output term in here, which I would put it, this is, what is it on here? SE1 divided by R sub 2. And then you have Q sub 5, C sub 5, and then this P sub 8. So this would be in here Q sub 5 divided by C sub 5. That minus, excuse me. And then this one, you have this P sub 8 divided by I sub 8. I'm going to put it over here, which is P sub 8 divided by I sub 8. And then let's build this thing. If you integrate this once, what do you get in here? You get P sub 8, right? Whenever you get a state variable like that, I usually put the scope so that But see, then this calls for it. See, it falls by itself. You multiply this by r sub 7 over I sub 8, and you can connect it right here. See, this of course is a minus sign in here and a plus sign over here. Yeah, this one has to come from here, so I'm going to do an integration here and produce again on this side is q sub 5, right? See here, this calls for 1 over c sub 5 over here, and you got this. But this other one comes from here, see? So if you bring it down here, multiplied by 1 over I sub 8, you can complete that. But this one in here comes from this one, see? So you come here and then you multiply by 1 over c sub 5 and you complete this one. Okay? So that's the block diagram for these ones. I think we're going to go over a little bit because I want you to have this e sub 5 and e sub 8 as also as the block diagram, so we can complete this. And this e sub 5, you realize is, I would just do it this way. All our summation points, you know, the output is e sub 5, and then of course an output in here. This is, what do you have in here? Q sub 5 over c sub 5. This one in here is q sub 5 comes over here. You could just do it this way. Right there is 1 over c sub 5, and then connect, and it's done for this.
Could you save that and put it on tab 2 as well?
I am going to as soon as I finish.
All right.
So we will put this in here. E sub 8. This is the summation. Here e sub 8. And then you have one that says this is q sub 5 over c sub 5. And the other one that is minus p sub 8 over times r sub 7 over I sub 8. This of course closer. But you see, these terms you already have. So I would, you know, you could pick this one up in here and complete this. And this other term, you already have it in here, see? So you could bring an entire line all from here to here and it's done. But just to be a little bit more consistent with these graphs, I just need p sub 8. So I would grab it from here, bring it down here, multiply this by r sub 7 over I sub 8, and I would complete this graph like that. And I am done. I have put the whole state space form in a block diagram form.